This is the third of 4 videos on finding the x-intercepts of the quadratic polynomials, quadratic functions. And this one explains my solutions to the worksheet. Now, my suggestion to you is to stop and do the worksheet before. See, I did the worksheet before too. You should do that before you watch this video. Now, once you've done it, then you can watch the video and look at my solutions that are also posted online. Okay, so the first question says, what does the quadratic formula tell you about a quadratic function? Well, that's what the previous video was all about. So if you don't know how to answer this, you better watch the previous video. Here's my answer though. My answer is if the function is ax squared plus bx plus c, then the quadratic formula tells you the locations of the x-intercepts, if there are any. And the way to tell if there are any is to look at the discriminant, the b squared minus 4ac part. If that's negative, then there are no x-intercepts. If that's 0, there's 1. And if it's positive, there are 2. Okay, now let's go on to problem number 2. And what I'll do is I'll do each of the parts of 2 and then graph them, which is 3, to explain it. Okay, so let's start off. 2a gives you this quadratic function. Now, you might think right away that I could just turn this into the factored form, right? Can we factor this? Well, let's see. We say y is, well, maybe there's a 2x, there's an x3, and let's see here, I want that. Well, does that work? Is that right? Is that right? Well, no, it's not. It's not right. You gotta be careful when you're doing this sort of thing, because this is 2x squared, looking good, 2x squared, minus x, minus 6x plus 3. So that's minus 7x instead of 5. So that's not what we wanted. So just factoring this one outright is probably not the best bet, because you probably get something like this one, which doesn't work. So instead, let's use the quadratic formula. So use let's use the quadratic formula. Now the quadratic formula is going to say the x-intercepts are negative b plus or minus square root b squared minus 4ac divided by 2a. All right, now let's put in the different parts here. The b is the negative 5. B squared is going to be the negative 5 squared. And here's where you got to watch those signs very carefully. So let's see, a is 2 and c is 3. And 2a. Okay. So here's that discriminant, the all-important discriminant, telling us how many x-intercepts we have. Well, let's look at this here. This is going to be a plus 5. The 2 minuses cancel out. The minus here is going to cancel itself out by negative 5 times negative 5. That's positive 25. Now what's this? This is 8 times 3. What's 8 times 3? 8 times 3 is 24. And 2 times 2 is 4. So this is 5, 4 plus or minus the square root of 1 is 25 minus 24. That's 1. So this is 5 plus or minus 1 divided by 4. And so what we're going to do now is we can write this out. This is 2 possible solutions. The first one is 5 plus 1 divided by 4. And it's 5 minus 1 divided by 4. I can simplify those. It's 6 divided by 4. And that's 4 divided by 4. So it is, this is equal to 3 halves, and it's equal to 1. So there are 2 intercepts, 2 x-intercepts, and that's what they are. I don't think I would have guessed these as far as factoring is concerned. So that's why the quadratic formula is handy. Okay, so let's sketch it. Let's sketch it. Now, once you have the x-intercepts, if it does have 2 x-intercepts, sketching is really easy. All you need to do, instead of that 4-step procedure that I told you about in the last class, all you need to do is mark those two x-intercepts. Let's see, where's 1? Here's 1. Now, where's 3/2? 3/2 is 1.5. Once you've marked those two x-intercepts and look at the A, it says, A means concave up. It's going to look like that. So your graph is just going to be concave up. Now, where is the y-intercept? The y-intercept is, of course, the same y-intercept that we had before. It's when x is equal to 0, that all drops away, and you're just left with 3. So that's what the sketch of the graph looks like. And that's why there are two x-intercepts. Now let's take a look at the next problem, 2b. So 2b looks like this. It looks like y is equal to 1/2 x squared minus 2x plus 2. Okay. Again, I'm not sure I'm going to want to factor this one outright. So let's see here. Probably what I should do is I should go ahead and write out the quadratic formula again. Negative b plus or minus square root b squared minus 4ac divided by 2a. Okay, and put in the pieces that I know. See, the negative b is a negative 2, plus or minus the negative 2 squared, minus 4, what's a? A is 1/2, and what's c? 2. Okay, and the 2a is 2 times 1/2. Okay, this is the reason why I don't really like to mix numbers. It's a little confusing if you use mixed numbers at this stage. Okay, so let's see, the 2 minuses cancel out, so I just get a 2, plus or minus. Let's see, what's negative 2 times negative 2? The negatives go away, negative 4. And here, let's see, these 2's cancel out, and I'm left with a 4. Here, my 2's cancel out, and I'm left with a 1. Okay, so this is 2 plus or minus, what's 4 minus 4? 0. What's the square root of 0? 0. What's 0 divided by 1? 0. Oh, okay. Plus or minus 0. So this means there is one x-intercept. Okay? Well, that's pretty good. So off we go, and let's go sketch this thing. So where is my x-intercept? Well, my x-intercept is at x equals 2, and there's only one of them. So it's at x equals 2. And because the 1/2 is positive, it's concave up. And where's my y-intercept? My y-intercept is at 2 also. It's concave up. So when I put all these pieces together, I get something like this. And again, the reason why there's one x-intercept is because it just touches down, just barely right there. Okay, let's look at the third example. So the third example is this one. Again, this looks pretty tempting to factor, but if you try to factor, it doesn't turn out for you so well. So let's try the quadratic formula. Okay. So what's the negative b? Well, that's negative 3. There's the 3. I'll put a parentheses for you. And let's see, there's a 9, because that's 3 squared. Jump the gun a little bit. Minus 4, what's a? 1. And what's c? 4. And it's divided by 2 times 1. So negative 3 plus or minus square root of 9 minus 16. Of course, at this point here, 9 minus 16 is negative. are no x-intercepts. Okay. So if we're looking at that, say it's negative, there are no x-intercepts. What does that mean? Well, that means that we're not going to cross the x-axis. How do I sketch this? Well, we fall back on that four-step procedure that I suggested for you before. So what does that four-step procedure say we ought to do? Well, the first step is we check out where is the y-intercept. The y-intercept is this c. So that's the y-intercept. That's at 4. Okay, I can sketch that. Here it is, at 4. The next thing that we need to do is we need negative b over 2a. That's our axis of symmetry. Let's see, negative b is negative 3 over 2 times 1. That's negative 3/2. So that's negative 1.5. So the axis of symmetry is there. Now, if you're following that four-step procedure, what should you do next? We should put in that negative 3/2 in for x and see what you get out. Now, we already know, though, that it cannot cross the x-axis because there are no x-intercepts. So for purposes of sketching, we could just sort of say, well, it's concave up. So it's going to look something like this already. We know that already. We can find this point if we care to. But just for the purposes of explaining that there are no x-intercepts, well, we don't really have to, or at least for explaining it graphically. But we can try. So let's put in. So y equals, I'm going to put in that negative 3/2 here. And let's see, this is, what's 3 squared? That's 9. What's 2 squared? That's 4. This is 9/4 plus, well, I get a negative 9/2 plus 4. And let's see here, 9/2 minus 9/4, that's a negative 9/4 plus 4. And if I put this on a common denominator, this is negative 9/4 plus 16/4, which that is a 7/4 positive. So this point right here, that is negative 3/2 7/4. Indeed, it is above the x-axis. So that's part C. Now, and that also is part C for problem 3. Okay, so now let's take a look at the last problem, problem 4. So problem 4 says we've got a single function here, and we're going to try to analyze different aspects of it. So problem 4 says we've got a rocket, and that rocket has a height as a function of time. Height as a function of time. And that's described by this equation here. So, let's see here. Let's note what these things mean. This is time. This is height. Okay, and so the problem asks a bunch of different questions. It asks, when will the rocket be at certain heights? So when will the rocket be, in part A, when will the rocket be at 20 feet above the ground? So when will h of t be 20? When will the height of the rocket be 20? Well, if h of t is 20, that means 20 is equal to negative 16 t squared plus 40t plus 2. Well, this is not in standard form. Let's put it in standard form. We get 0 is negative 16 t squared plus 40t minus 18. Okay? Well, let's check the discriminant. First of all, how many points are there going to be? So, when will it happen, and will it ever happen, in fact? So let's go find it. X is equal to negative b, that's plus or minus the square root of b squared minus 4 times a times c. And now wait, what have I done wrong? I need to bring in those minus signs. The minus 18 and the minus 16. Do not forget the minus signs. And then divided by 2a. And again, don't forget the minus sign. Okay, well, if you do this out, you get minus 40 plus or minus square root of 448 divided by minus 32. I don't know what this number is like as a decimal, or these two numbers are as a decimal, but there's definitely two of them because the discriminant is positive. So there are 2 times where this happens. This is a perfectly acceptable answer, perfectly acceptable way to leave the answer. Okay, well, let's now take a look at part B. Part B is basically the same kind of question, but the height is different. So when will the rocket be at a slightly different height? When will it be 27 feet in the air? Okay, well, again, this is not in standard form. Let's make it so. And let's go ahead and write out the equation of the X-intercepts using the quadratic equation. And again, beware of your minus signs, or be aware of your minus signs. And in this case here, we get minus 40 plus or minus. And it turns out that this number here, when you work it out and check on your calculator, this is 0. So this is minus 40 plus or minus 0, such as minus 40, divided by negative 32. And of course, the minus signs go away. And again, that's a perfectly acceptable number. You don't have to simplify that fraction. So this tells us that there's only one time where this happens. It's worth noting that this is negative b over 2a. This is actually at the peak of its flights. This is the peak height. The rocket goes no higher. Now, if you didn't notice that and were just asked for when will the rocket be, well, the next one says, when will the rocket be 35 feet? At this point here, since you know this peak height, it never gets to 35 feet. So you don't have to say it. You don't have to do any computation if you've done this one already. If you've done this one already and you say, this is the peak height, then you know, well, anything higher, say 35 feet for part C, it's never getting there. Of course, you can check. I'll show you how to check. So when is it 35 feet? So we already know this is going to come out with a no. This is 35 is equal to negative 16t squared plus 40t plus 2. Again, we write it in standard form. Minus 33. And let's just check the discriminant. That's b squared minus 4ac. And what's b squared? That's 40 squared. 4 times a times c. When you do this out, this ends up being negative 512. It's negative, so there is no solution. There's no which means, or put another way, there is no x-intercept. for this quadratic polynomial. Now, what have we been doing? What do I mean by no solution? Let's go take a look at what this function looks like. Remember, the two axes are height and time. There's time, and there's height as a function of time. Now, let's see. Where's the y-intercept, or the h-intercept in this case, the height? Well, that's when t is equal to 0. The rocket starts out at 2 meters. And then it's going to go up and then down. It's concave down because of the negative sign there. So it's going to go up, and it's going to come down. Now, we were asked, what times are it when it is height 20 feet? So the answer to part A, this is part A, was asking you to find this time and that time. Now, for part B, we were asked at 27. And we found just one solution. That's because we just hit the vertex of this parabola. And then, finally, for part C, we were asked, when is it 35 feet? 35 feet puts you up here. And we see that it never, ever gets there. Never gets that high. Okay? And that finishes off the worksheet. The last video is a derivation of the quadratic formula. It tells you how it came to be. How do we find it? So, hope you'll see that last one.